Hello and welcome to another virtual talk with Warwick Data Science Society. I'm Yasser Qureshi, the Outreach and Talks Officer. Today we have an interesting collaboration with Warwick Psychology Society and Warwick Data Science Society, and we'll be talking about the one-word Turing test. You may have seen a lot of social media posts about this, where you had to choose a word between two, where one of them was written by a human. Our aim today is to explain what the Turing test is and some insights we learned about this project. One of our speakers today is Professor Thomas Hills. He's the Professor of Psychology at the university. He's the Director of the Bridges Leverhulme Doctoral Training Centre, apologies if I said that wrong, and the Director of the Warwick MSc in Behavioural and Data Science. He also co-directs Warwick's Global Research Priority in Behavioural Science and is currently a Fellow of the Alan Turing Institute. He'll be talking about what the Turing test is and its significance. Our other speaker is our very own Warwick Data Science Society President Tim. He'll discuss a collaboration between Psychology Society and Warwick Data Science Society to develop the one-word Turing test, and he'll talk about what we found out. Let me pass on to Thomas, who will begin the talk.
All right, thanks, Yasser. Is it okay? Can I start now? Okay, great. So thanks. I'm Thomas Hills. I'm a professor of psychology at the University of Warwick, and I'm originally trained as a biologist. And so my goal here is to sort of talk about, in part, the basis for the Turing test and why it's meaningful. And the Turing test was developed by Alan Turing around the 1950s. And he was thinking about, to quote him, he basically said a computer is intelligent if it can fool people into thinking it is a person. And you can imagine that at that time when people are starting to, at least in science fiction, thinking about the future intelligence of computers and how will we ever establish whether they're intelligent or not. Maybe they were thinking about things like, when might we give computers rights or robots rights, or would they have free will and would they have minds like ours? And of course, that question has been around for a long time. Even Leibniz, who was a philosopher thinking about things quite some time ago, he was asking questions about whether or not you could see consciousness in an individual, right? If you could blow up a mind to, say, be the size of a mill, like a factory or something like that, and you could walk around inside it, would you ever see something like consciousness or the processing units? And so Turing is kind of sweeping a lot of that aside in a very materialistic kind of fashion. And so he's basically saying, if the mind, it's rather functionalist in a way. It's basically saying if some type of computational hardware can act like a mind, then we'll call it intelligent. And that position is even, of course, juxtaposed against what many of us think of in terms of like minds, right? So, for example, for hundreds of years, we had a sort of dualistic perspective on the mind, where we might think that the mind is somehow separate from the brain. And it's only been, I'd say, in the last 100 or so years where we've started looking with the neuroscience and behavioral psychology to establish that, when the mind does stuff, when the brain does stuff, the mind thinks things, right? Or the body has particular behaviors. And so the Turing test is a rather simple test, actually. And if you remember, if you've ever seen Blade Runner, you might remember the Voight-Kampff test, right? And the idea with the Voight-Kampff test was you're going to take these machines and you're going to try to decide whether or not they're human or not. And the only way to do that, because they've been constructed to effectively have the same kind of biology, the only way to do that is to ask them a series of questions. And as I'll get to in a minute, this has a lot of foresight for the way we think about artificial intelligence. Well, the kind of questions that they used in Blade Runner and the Voight-Kampff test was, they were looking for signs of empathy. So they would ask questions like, imagine that you're in a desert and you see a tortoise and it's on its back, or you push it over on its back, and they're looking at the motion of the robot's eyes, right? And they're looking for signs of basically some signs of stress associated with this. Later on, one of the simulator, or one of the robots gets asked, do you, how would you behave if your husband put a picture of a naked woman on the wall in your home, right? And so in these cases, they're looking for signs of stress. And in Alan Turing's test, you can ask whatever you want. So originally, he sort of borrowed this idea, I think, from what was probably a kind of parlor game where you were trying to determine whether a person was a man or a woman. And he just sort of modified it a little bit and basically said, if you could ask a computer in another room, so you can't see them, a series of questions, could you, in 5 minutes, determine whether or not they are a human or not? And it's interesting to think, what kinds of questions would you ask in these cases? And there have been a number of people over the past, let's say, since Turing developed this test, there have been a number of individuals who've tried to address this in different ways. There was, for a long time, there was a computer program called Eliza that was developed by some computer scientists that you could interact with. And I used to have my students interact with this. They were in an education program for thinking about psychology, basically, because with Eliza, what she's doing, she's using a kind of, so Eliza's a program, and you can type questions into Eliza, or Eliza will interact with you and she'll ask you questions as well. And she uses something that you'll all be familiar with, which is a Rogerian psychology. So with Rogerian psychology, whatever you say to me, I just turn it around into a question and ask it back to you. So you could say, I'm not feeling very well. And I'll say, well, why don't you think you're feeling very well? And you might say, well, I had a bad day. And then I could say something like, well, why was the day so bad, right? And so this is just a little trick of natural language processing. Basically, I take a particular sentence you give me, I modify it a little bit, and I feed it back to you. And even the developers of Eliza were surprised to find that the secretaries and other individuals that they worked with were using Eliza to deal with their own problems, right? So they were actually using this piece of software in a, I don't know, what you might call a kind of serviceable way. Eliza wasn't built to actually do Rogerian psychology. It was built as a kind of toy, a sort of demonstration, but it became incredibly popular because people had meaningful therapeutic experiences with Eliza. And there have been many other developments since that. Eugene Gustman is so you could say another piece of artificial intelligence that pretends to be a young Ukrainian boy, and this one has passed the Turing test a number of times now and won a number of different contests associated with it. And people have criticized those tests for lots of reasons, because you might imagine that, for example, you might ask, people would ask Eugene, for example, like, how many legs does a giraffe have? And Eugene would make a joke, right? So Eugene would say, oh, two or four, maybe three, and then put kind of an emoticon, like a smiley face or something like that. And it didn't really matter what kind of animal you asked. It always gave basically the same answer. And so it sort of used humor to avoid the response. But nonetheless, people had trouble determining. And Turing even suggested that, I think it was by the year 2000, that some large proportion of people would be fooled by the Turing test, or would be fooled by computers into believing they were human. And so the one thing that's really interesting to think about with respect to the Turing test, because it's quite practical. if you're on Twitter, a lot of the things that you're interacting with on Twitter, believe it or not, are bots. There's a friend of mine, Filippo Menser, who runs a laboratory at Indiana University, and he's established that for some people, as much as a third of the Twitter agents out there are actually bots. And what's kind of funny about this is that if you ask, he's done a number of studies with different political parties. So, for example, if you're a Democrat in the U.S., are you better able at detecting bots, say, than Republicans are? And it turns out that, in fact, you are. But that's because Democrats tend to think that people with conservative values are bots, right? Whereas Republicans tend to think that bots are people. So this is an article that he and I have described this in an article that's coming out in Scientific American in a few months. We're basically just talking about how the things that you interact with on the internet are increasingly becoming bots that you could say they're designed in a way to pass a Turing test that doesn't quite satisfy the constraints that Turing set out. You don't have to, they're not sitting in another room and you don't get 5 minutes. They present you with something and you have to establish whether this is, could say true or false, but also implicitly you kind of want to know, is there a human behind the information that I'm getting or not? And there's countless decisions that are being made on your behalf now by algorithms where there's a person that kind of works as the front end, and they're not telling you that there's an algorithm working behind it. And then, you might want to know, well, for example, recently I didn't get a bank loan. And I asked them, so what's going on? And they said, oh, they didn't tell me that they were giving the algorithm to, they were giving my information to an algorithm, but I found out that they were because I changed my name slightly. I changed my name from Dr. Thomas Hills to Professor Thomas Hills. And when I changed it to Doctor, which is what my old designation was, I got the loan. But that's because the algorithm, in this case, the person on the front end, just changed the name when she typed it into the software that she gave to the algorithm. But the algorithm didn't recognize the difference between, didn't recognize that I was the same person if I was Dr. Thomas Hills versus Professor Thomas Hills. So when I changed my name to Dr. Thomas Hills, I get the loan. If I change it to Professor Thomas Hills, the algorithm doesn't have the semantics. It doesn't have a way to understand that doctor and professor are basically the same thing. And so, in fact, they're just a title. All it recognizes is that, if this is a set of information and there's another set of information before that represents the person who has the bank account, then these two people aren't the same, so we can't give this guy the bank loan. So that's just one example. In Cathy O'Neill's book, Weapons of Math Destruction, she talks about the many, many different places, and this is a great book, by the way. She talks about the many, many different places that algorithms, which are making decisions for people to behave in certain ways. So, for example, algorithms might decide where police go to look for crimes. And so in this case, it looks like it's a human decision because there's a policeman walking around on the pavement, but the policeman's actually being instructed to do by some AI somewhere else. So the question is this person behaving like a human? You can see that the boundaries, the boundaries between artificial intelligence and humanity are being broken down all the time by the many different relationships we have. So thanks a lot for having me here to talk about this, Tim and Yasser, because I think this is a really interesting problem. And the particular one-word Turing test that Tim's going to describe in a second is a really great example of a place where we can still do really cool research on a very simplified, if you will, kind of version of the Turing test that might give us insight into ways to distinguish between, say, real humans, if you will, and artificial intelligent agents, perhaps much like the void comp test in the future. So thanks very much. I'm going to hand this over to Tim now.
Okay, hello everyone. I'm Tim. I'm the president of Warwick Data Science Society. I'd start by welcoming everyone to this talk and giving a massive thank you to Thomas for offering his time to talk a bit about the background and historical context of the Turing test, specifically with how it relates to psychology and machine intelligence. So in my part of the talk, I'm going to discuss a collaboration between Warwick Data Science Society and Warwick Psychology Society about the one-word Turing test, also known as the minimal Turing test. And so we're going to just start by discussing exactly what this is and how we went about implementing it. And so we'll start with that, the setup of the one-word Turing test. So as the name might suggest, this is a variant of the Turing test, kind of a slimmed down version, in which rather than determining the humanity of an agent by a full conversation, we focus just on a single word. And so a common setup of this problem is to have an AI and a human both choose a word from the English language. And then these are given to a human judge that then has to determine which of these words was created or chosen by the human. And the judge has no knowledge of which one was the AI or the human. They have to guess based on the words alone. And so in the traditional setup of this game, the one determined to be the AI is then vaporized, but in our slightly friendlier version, we just award a point to whichever agent was determined to be the human by the judge. And so this is a very interesting scenario because it takes the whole notion of the Turing test and really kind of narrows it down to its core. And there's a few questions this raises, which are kind of the motivating questions for why we wanted to work on this project. And a few of them are listed here. So an example would be, what words are the most or least likely to be selected by the judge? In other words, which words display the most humanity and which ones appear the most artificial? We also wondered, are there any asymmetries between the words that are chosen by the human participants and by the judge? Perhaps there's some words that are more likely to be chosen by a human to prove their humanity, but seem too obvious to the judge and so get disregarded as words generated by an AI. And also, what exactly about a word predicts its success in a game like this? Are there certain semantic properties, say the humor in a word, how kind of violent the word is, the length of it perhaps? Is there any clues we can gain from this as to what makes a word more human? And so this is just a small selection of the sort of questions we had in mind when deciding to take on this project. And so to tackle this project, we decided to build our own one-word Turing test. And so we created a web application that was accessible to anyone to either play the judge or a participant. And so we can see that at this link here. And so this is an example of what it might look like. Two words are displayed to me, one generated by a human and one by an AI. And then it is the judge's role, so myself here, to determine which one I think the human came up with. And of these two words here, I might favor anti-just establishmentarianism. Pizza seems a bit too obvious. So I would select that. And for the next one, probably dinosaur. And then once you've submitted 10 of these words, you're then free to, 10 of these comparisons, you're then free to submit your own word to battle against the AI and see how your word ranks. And so before I move on, I would like to offer some acknowledgements. First to our team of developers at Warwick Data Science Society for doing an excellent job in crafting this application, and to Warwick Psychology Society for promoting it within their student base. And for Thomas, as well as giving this talk, he's helped to share this with some students in the modules that he runs. So big thank you to all those people. And so to follow that, I have a confession, which is that actually there was no AI in our web application. All the words in there were generated by humans. It was human word against human word. But in this slide and the next, I want to try and convince you that actually this doesn't matter. That adding an AI to this application is superfluous, and if anything, distracts us away from our goal. And so to explain why an AI doesn't add anything here, I want to ask the question of what an optimal AI for this game would look like. And so we can imagine an AI generated based on the historical results, the historical comparisons which words played against each other and which words won. And from that, we could build up a table looking something like this one on the right, in which for every word, we'd know how often it was played and how often of those comparisons did it win. And from that, we generate a probability, just by taking the ratio there, of how likely a certain word was to win in a comparison. And so if an AI had access to this information for a large number of historical comparisons, well, if we were just playing a single game, so just a one-off version of this against a human, the best thing for them to do would just be to pick whichever word was shown in history to be the most likely to win. Because remember, when you're selecting a word, you have no knowledge of what your opponent is doing. And so the best you can really do is pick the most probable candidate. If, for example, this was a repeated game, so playing again and again with the same judge, always picking that most probable word would be a bad strategy. It would be obvious you're always doing the same. And so instead, you might want to pick words proportionally to how likely they are to win. So pick words with a high probability of winning more often and low probability less often. And that can be shown to be an optimal strategy under certain conditions. You might also be thinking, well, what if we don't have all this data available? What if we're starting from scratch? Well, in that case, this is actually a form of a problem known as the Bernoulli bandit in statistics. And I'm not going to get into the details of this, but the important takeaway message is that we've solved this. In 1985, so decades ago, we proved the optimal solution for the Bernoulli bandit. And so even in that most advanced case, the most complicated one that could possibly exist in this world, we solved it, and there's nothing really to be added by developing an AI to look at that. So instead, we decided to focus on only using human words and focus on the insights we could draw from the comparisons. But the important thing was the judge still believed there was an AI, and that's what made the game work, even though in reality there wasn't an AI. So we'll talk in a moment about the actual results we had by analyzing the data we obtained. But first we'll talk about the participation rates. So in total, we had over 2,000 comparisons of different words. So 2,000 different pairs for which someone picked which word they thought was the most human. And from that, we had around 80 words submitted by users to kind of battle out and see which ones were the best. And then in total, we had over 200 people participating in this. So we're very thankful to have so many people taking part and giving us a really rich source of data to analyze and try and draw insights from. And so on top of those 80 words that we included, that were submitted by users, under the suggestion of Thomas, we also added 5,000 seed words. So these were words submitted by WDSS that would then be chosen with equal probability to the user submitted words, so bounce between those two. And the reason for including these is that we had information on various properties of these words. For example, we'll see later, we knew how humorous these words were judged to be by humans. And so from that, we could start answering those questions about how the sentiment of words impacted their likelihood of being chosen to be human. And so once we had all these comparisons, the next question was, how do we go from those pairwise comparisons to ranking all of these words and determining which are the most and least human? And so we decided to use a ranking system known as the ELO rating system. I'm not going to get into the technical details of this. Basically, it's a system taken from the game of chess, and it's also valid for any sort of game where you have pairwise comparisons. So 1-versus-1 games, we want to understand the overall ranking of players from those 1-versus-1 scenarios. And the reason we use a system like ELO is that it guarantees that we have a valid rating system, even though our comparisons are sparse. So even though maybe word A was never played against word B, if those were both played against word C, D, and E, from that we could generate a good approximation, a good idea of how word A would do against word B. And so the ELO system captures all that in mathematical formulas and gives a very robust response. And so now, I know the bit that people care about the most is the results of this. You know, what are the answers to those motivating questions I set out earlier in this talk. And the first most pressing question is, what word do we determine to be the most human? And so this is a column chart of the top 10 rated words that were submitted by users. And so only 80 were submitted by users. It's a small selection of words. But of those, the most human word we found was molecular. It's a very scientific, technical word. It's hard to draw insights from one word alone, but we can see that this does lead by a fair gap. And with the amount of comparisons we have, you can show mathematically that these ELA ratings are fairly stable, at least within the user-submitted words. And following that, we have the word fake. So I guess quite a clever word there, given the context. And then a few words related to magic, so magic and Expelliarmus. And then some very happy words, so hope and nice. So overall, it's quite a positive view of humanity. But then again, it is hard just from these examples to paint the bigger picture. We also had the ratings for our seed words, the ones that we put in. And by quite a large margin, the most human word was crunch, followed by bloodbath. So perhaps that's a worrying sign. There's some very dark words there. But then again, we do follow that up with memes and love. So I guess maybe a brief insight into this could be they're quite strong words, either very strong negative or quite strong positive emotions. I guess we have wasteland here as well. So these seed words, because there was more of them, the comparisons were more sparse. We can't trust these ratings as much without more data. But definitely this top one here, crunch, there is quite a lot of evidence that that is a very human word, at least judged by the people participating in our experiment. So then on the other hand, we have the least human words. So again, these are the ones submitted by users. Hopefully you don't see yours here, and these didn't do too well. And so we have words like supercalifragilisticexpialidocious, empathy, bruh. And I think to summarize a few of these, I guess transhumanism is a good example, is they're words that try a bit too hard. They're trying, too desperately to prove how human they are, to the point of going a bit over the top. And I think the judges then determine them to be more likely to be from an AI. So that's a very brief conclusion from that, but there probably are more insights to gain in the future. And in terms of the seed words, the lowest rated, were again some quite over the top words like God and death, quite obvious ones there. But interestingly, by again quite a fair margin, the lowest rated word was fitness. And this actually might be demonstrating some bias here, that maybe people weren't choosing exactly what seemed most human, but just choosing against words that weren't too popular. So fitness is difficult, and so you might be predisposed to choose against that one. But we plan to do more analysis in the future to try and really pull out some greater insights, and I'll talk more about that later in this talk. So another question we asked in the motivating questions section was about analysing the asymmetries between submitted words and words that were judged to be human. And unfortunately, we did not collect enough data to do this. Even though we had a lot of comparisons, not enough words were submitted to the system. In fact, only one word, dubious, was submitted twice. And so we can't really draw any conclusions from that. But the goal is over the rest of the term, I'll talk about this more in the next section, for us to expand this application even further, collect more data, and then publish some further research on this, hopefully answering this question. And so another question we asked was about the semantics of words and whether that can predict how human a word is. And I guess the conclusion from this example is it's complicated. So here we looked at the humor norms for all of our seed words. So basically how humorous they were judged to be by an independent set of judges. And we regressed these, or we regressed the rating of how human the words were against this humor, and found that maybe a slight positive correlation, but really quite weak, a p-value of 0.6, which is definitely not statistically significant. And so maybe this is a case of getting more data, but it's more likely the case that, humanity is complicated. And that should come as no surprise that one axis alone, one dimension of humor is not enough to capture that variability. And so hopefully in the future, with more detailed analysis, we can actually start to draw some insight based on the data we have available. And so that leads me to the next steps, because this was, I guess, the initial trial of this project. And this talk is just discussing the initial insights we gained, but we don't plan to stop here. I think we've demonstrated that there is something here. There are interesting ideas. It's just a matter of building more data and having a deeper dive into the data we collect. And so our next step is to scale up. So the first thing we're going to do is activate an email system to send out rankings of any words that were submitted whenever people provided an email address. So if you provide an email address, over the next few weeks, you should get an email saying how well your word did. So hopefully that would be good to know. And we're also going to try and improve the robustness of the app. So making sure we have the right features in place to stop people from abusing it and corrupting our data. And then once we've got that sorted, we'll then feel confident in sharing this further afield than the university, hopefully reaching more people to participate, gaining more data, and being able to drive even further insight. And we're also going to modify the algorithm we're using to pick the two words that go against each other to try and improve the rate of convergence, to get to answers quicker with less data. And so this leads me to talking about how you can get involved, because we're looking for a student to help analyze this data. And so preferably we're looking for a psychology or at least a non-STEM student to get involved in this. We're a very interdisciplinary society, but if you do not have that background, then we are also open to you applying for this position. And so all we require is a basic knowledge of either R or Python. And when I mean basic, I really do mean basic. There will be plenty of support from myself and our research team to guide you along the way in deciding what statistics and what kind of coding techniques to use. It's really, we're looking for someone with an interest in data science and this project. And so the end goal for this is to publish on our research blog, research.wdss.io. If you haven't seen that already, check it out. There's some great student-led research on there. It will give you an idea for the sort of thing we're aiming for. And then if you are interested in getting involved in this, you can simply apply at research@wdss.io. Just send us an email saying that you're interested in this, and then we'll get in touch to discuss further and kind of share more details about that. And so the final thing I want to mention is other opportunities going on in the society for psychology and students related to that sort of discipline. Because Warwick Data Science Society is currently recruiting for a social sciences/politics ambassador. And so this is a role that will sit between our society and various different social science subjects to try and, to bridge the gap between the technical side of data science and different domains. And so this will support with our teaching, with our research, and with our talks to make sure they are relevant to students, hopefully such as yourself, interested in these sorts of social science domains. So if you're interested in getting involved in that, just send us an email to hello@wdss.io, just letting us know that you're interested and a bit about you, and then we can follow up to discuss further if the role is suitable. So with that, thank you everyone for attending this talk. I look forward to publishing this research post later in the term, hopefully with some even more interesting insights. So with that, I'll pass back over to Yasser.
Thanks, Tim. I'm a little bit annoyed that there was no real AI there, but anyway, with that, we end our talk. A big thank you to Professor Thomas Hills for joining us and sharing these insights. And if you enjoyed the talk, please leave a like and subscribe to see more content like this. Our social will be in the description, so check those out as well. Our next event is on data horror stories. Here we'll be talking about, we'll be sharing some tales of dodgy statistics, corrupt data, and evil Excel. You'll learn about some of the common data management flaws, but also how to avoid them. Check out our Facebook page for more details on our event. And with that, thanks again, and we'll see you next time.